So I want to talk a little bit about aqueous ozone as an effective alternative for cleaning and sanitation. This should probably look familiar to most of you guys. You have the foot foam where you're going from one door to another for personnel cleaning feet, that kind of thing, or sanitary mat, or you're using quaternary ammonia or some other kind of strong disinfectant or sanitizing agent. I think this is frequently something that is contracted out. Usually occurs on third shift whenever they're doing their cleaning. So if you don't have videotape or something going to see what's happening, you may not even realize what's happening with the cleaning. So ozone is cold water treatment. You don't heat it, so you save energy. It's great for cleaning in place or sanitizing in place. You can use this on all surfaces. You can use it if you want to reuse water, you can sanitize it with ozone. You can sanitize your product water. You can have direct food contact with your product or your beverage. It doesn't have any odor. It has no taste. And after it's done its job sanitizing, it reverts back to oxygen and water. So its ozone is O3. So you take an oxygen-rich gas, hit it with a little bit of electricity, you split apart some oxygen molecules into atoms. Those recombine with another oxygen molecule and form O3. It sounds pretty simple. I know it's more complicated than that. So some of its properties are, it's unstorable. So you can't take a bucket and fill it with ozone water and use it all day. It has a lifespan of probably, depending on temperature and pH and some other things, probably 15 minutes or less. It has, when it breaks down, I said it reverts back to oxygen and water. You can't store it. It's generated and used where you want it. So typically what I've done, I've designed a couple of systems for people that are closed loop, kind of like your water supply system now. It's just PVC pipe. It's a circulating system so that there's always fresh ozonated water at a known concentration at different drop down points around the plant. That water then goes back to ozone destruct. It's re-ozonated and into a distribution tank, and off it goes again. So you can use this ozone as a gas or a liquid. When you use it as a gas, you really need to be careful because the exposure level is very low for humans. So you want to make sure that if you're ozonating, say, a storage room or something where you've had maybe fungus or mold or bacteria, something that needs to be cleaned as a whole room, you can gasify it with that. But again, it can be very dangerous. Aqueous, you can drink it. It's no big deal. If you have bottled water on your desk, you had ozone in that. It's something that's added because it has no flavor, no residue. It reverts back to oxygen and water. And beverages are one of the first places that was used originally in Germany to clean out wine casks. So it removes the color, it kills the microbes, doesn't leave any residue. It's approved. You don't have to worry about getting approval from different agencies. We first learned about this from a USDA inspector. He recommended it to one of the food companies that we went to. I don't believe they've installed it. I designed a system for them. But he said, you guys ought to look at this because you're spending a lot of money. USDA doesn't really have that kind of a reputation. But in this case, I think they made a good recommendation. So it's approved by OSHA. It's approved by USDA, EPA, FDA, all the A's. Which was no minor feat to get that accomplished. In the beginning, I identified Beth Hamill She is the person who got that approved by all these different agencies. So how does it sanitize? You have that weak bond between that third oxygen molecule. So as that ozone comes in contact with a bacterium, that extra oxygen atom breaks off. It comes in contact with the cell of the membrane. It ruptures that membrane cell and kills that organism right then. And it bursts it, destroys it. Then as those guts of that organism are released, it also attacks those. So you can actually break down DNA. We talked about the Legionella that's inside the microbes or the amoebas. It attacks them, it keeps working and kills them. And then they don't have a chance to build up a resistance to it. So we're talking about oxidation. So this is oxidation comparison between common cleaning and sanitizing chemicals. So ozone has an oxidation strength of about 2.7. Chlorine dioxide is 0.95. Hydrogen peroxide is 1.78. Perioxytic acid, or perioxyacetic acid, is 1.81. So it is, as far as these go, it's the best functioning oxidizing sanitizer that there is. So what's it destroy? Disinfecting potential of 10 to 4,000 times free chlorine, depending on the pH, the temperature, and the organism. We talked about Cryptosporidium parvum. It destroys some of the harder microbes to kill. So Listeria, some of the things that are kind of residual, as it goes through, it's applied, goes down the drain, it cleans your drains and other things until there's no ozone left in it. So since it destroys the bacteria and the viruses, they're not able to develop a tolerance. And we talked about biofilms before. So this ruptures those biofilms, breaks them up. As it's oxidizing the outside, it just keeps working on them. As the microbes inside are released, it continues killing those. And any of the other DNA that's released, it keeps breaking up that. So byproducts, I already said, was oxygen and water, no residue, no aftertaste. It's just a simple product to use. So common commercial uses, I talked about the drinking water. Laundries are using these to replace bleach. You've seen OxyClean commercials and things on TV. It's kind of the same potential, same thing, that has more oxygen added to it. So it removes stains, it removes, kills the microbes, sanitizes it, but doesn't have the smell or the bleach has. It's used in pulp and paper manufacturing where they typically use bleach. I worked with a paper plant in Augusta, Georgia. They had a bleach factory built just for them, pipelines straight over to them, and all that was their only client, was to make bleach for the paper industry. Agriculture irrigation water, especially in food production, if you're growing lettuce, if you don't have contaminated water to put on there, then your contaminants and possibility of E. coli and other things we read in the news are reduced. Some of the things they do in California when they're cutting your celery, it goes into an ozonated water tank out in the field, and then it's packaged and sent to you at the grocery store. So there's no rinsing required. It evaporates as it goes through the whole transmit procedure, so it works pretty well. And then groundwater remediation, I'm not sure exactly how it works with that, but that's something that Beth said, so blame her. In food production, it's a lot of clean in place, surface sanitation. You can do process and product water. You have food direct contact with your food. If you're packaging chicken or something, you can have this set up so the food passes through a stationary spray of ozone water to kill any bacteria before it comes in contact with your systems. So this is typically what an ozone system looks like. This one was from Dell Ozone. That's who Beth worked for. they quit doing anything with food products, and now they're focusing strictly on pools and saunas. This is just a typical one to give you an idea of what the footprint is. Your storage tanks will be the biggest, take up the most room, but just a typical system has an ozone generator and a ozone destruct for a closed loop system. The water is ozonated, goes in the storage tank, and then distributed from there throughout the plant. So you can hard plumb this. Like I just said, you can have a fixed sprayer or a handheld sprayer. You can flood it. It's not a high pressure system. If you go over about 20 psi, that extra third oxygen atom is going to break off before it hits the surface that you're using. So about 20 psi, you don't want to shear that free oxygen off. You'd also, if you're using a high pressure spray, there's the possibility that any contaminant is here. You're just pushing it on ahead of you with the spray. If you flood it nice and slow, then it kills the microbes on the surfaces it's applied to. Again, it's cold water. Colder the better. 70 degrees is probably about the upper limit of what it can operate at a reasonable amount of lifetime. It's compatible with most materials. So stainless is fine, aluminum fine, painted concrete and wood is fine, plastics fine, some things that's not fine. Mild steel that's uncoated, it's going to rust just like any mild steel that's uncoated, exposed to the air or water. And it's really not compatible with natural latex. So if you're using latex gloves in your processes, I think most people are moved on from that, but it will just kind of turn to goo, so it's not something you really want. So you can sanitize anything with this. I wouldn't recommend spraying it on electrical components, but in the pictures we saw, so in this picture, there's electrical back here, but you're not hosing those down. And they're designed to be in a wet environment anyway. But, any conveyors, prep surfaces, you can spray your ceilings and your walls just like you normally would. Doesn't have any effect. And then as it goes down the drains, it keeps working and keeping those clean until there's no ozone left. It may help reduce fats, oils, and greases on surfaces, but that's not what it's made for. It's to control, it's to sanitize, not to degrease. And it also reduces the buildup of biofilms. And you can see that in this picture. These are two conveyor belts. I think those are peaches that are being processed. Both these belts were cleaned 11 days ago. This one was cleaned with ozone, and this was cleaned with a regular sanitizer. And this one you can see where the buildup of biofilm, that's why that's a different color. And this one has eliminated that biofilm buildup. This is ready to eat meat conveyor, just being hosed off with ozone as part of the sanitizing system. And this one down here is a surface prep area, and it's being cleaned. You see, it's splashing, but it's not high pressure where it's really blowing it around a lot. So, as I said, this presentation was courtesy of Beth Hamill. She has her own consulting service, O3 Consulting. Has a lot of experience in food work. I've called her on the phone talking to her about different projects, and she's in South America, and she's over in Europe and all kinds of places, so she gets around. But here's her contact information is provided here. I'd like to thank you for your time.